Hello everybody, let's make this building randomize thing. It has the buildings, then the buildings have windows which are randomized, and the windows are lighting up which are also randomized. So let's see how this is done. My name is Manu Järvinen and I try to keep this short and sweet, but I have a fear that this will be quite a long tutorial. But let's begin. So let's look at the scene. I use a pre-made scene. I have these buildings here in one collection called buildings, and then I have windows and window plane that is the light up window, lit up. It's important that all of these objects have a scale of 1 and no rotation. Well, it's a good habit at least. Then there is these cameras and lights, and I have one point here. This is only like one vertex object with one vertex. That will be the point from which the buildings will be grown out from the central point. And then we have the ground, and we can actually already start now. So let's duplicate the ground and let's put it a little bit like on the top of the ground, and this will be our geometry nodes buildings. For the clarity's sake, let's put red as the color of the buildings, and for now I will use only I pressed Ctrl Shift and click to select a rectangle, and let's go to the object data and Vertex Groups, and let's assign a Vertex Group buildings, and assign, and let's go to modifiers and select mask and buildings. So now we have defined the place for the buildings. We can later add more geometry to for the buildings if needed, but this is good for now. So that's it for the meshes. Now let's dive in for the geometry nodes. So we can go to the geometry node editor and have this object selected and click new. It will create the geometry nodes modifier on top of the mask which is important, that it's on top of the it is calculated after the mask. Okay. Then let's see, I have like 100 nodes here. So let's start with instance on points. And the instance will be collection info, buildings, and these I can show you. If you put instance here, all the buildings in the collection are placed on top of each vertex. So we need to put separate children and reset children. And pick instance. That was the most important thing. These two checkboxes make sure that the buildings get into the geometry, and apparently it doesn't matter if we use original or relative. I must also note that I have material that is for the buildings. I have random objecting for random for the color ramp, and the building colors are randomized from that, and this will be annoyance later on, because well, I can show you. So here we see the material is okay at first, but then when the lights come up, the material starts to flicker. So that is absolutely something that we don't want. So I will keep an eye on that we don't make the same mistake again. Okay, let's continue. So now the buildings are like all the short ones are on one row, and the tall buildings are on another row. So we need more randomizing. So let's go to the geometry nodes and select the object. If you have different modifier selected, you need to click here to activate the geometry nodes. And let's put instance index as random. Which is random value, and let's use integer, and you can use some kind of, as you can see, the buildings get more randomized, which is good. So that's that. then we might, well, I will do it this anyway. So there is this node called mesh to points. So now the buildings sit on top of vertices. Yes, this node does nothing if we put it on vertices, but we might wanna use faces and put this here. So well, it just puts the buildings on top of faces instead of vertices. Well, that's quite self-explanatory. But now we get to the more interesting stuff, because you can use random value to drive the selection, I think. No? If you put it on float. Okay. Apparently, yeah. So this is one way to have the buildings grow, but this is not a good way, because I think, yeah, the colors start to flicker. So we need a different kind of method, and that method is to randomize the scale of the objects. But we need certain values for that. I will put 0 and 2, and the float is float. Away for a second. I press Ctrl and right click to cut the cord. What we could do now is to join the base geometry, just so we see where the buildings are located. So let's add a value node, and we can put, what is this, hashtag frame in here, so that it is now the frame number, which grows infinitely. And let's use math node utilities math and divide, so that we get smaller numbers like 66. So that means, well, I don't need to explain, I can show. If we plug this to scale, the buildings grow very fast from 0 to 1 and beyond. And divide, of course, makes the situation happen a little bit slower. Then let's put float curve. This is something I really like as an animator. So it starts, the growing starts slowly, but then it goes all the way to 1, and then it bounces and bounces and bounces, so that it ends up here. So now we can see we could use the clamp node, but for this time let's use math node with multiply with 1 and clamp that. Okay. This is what I always forget to do. This needs to go to value, not to the factor. Every time I make a float curve and stick it to the noodles, I forget that it needs to be on the value. So let's try to remember that. Now you can see that the growth follows what we drew on here, and we can use the divide value to drive the speed of the bounce. 66 is quite good, but let's put a, what is it, Control J, yes. Let's put a frame here to remind us that this is bounce speed. Okay. But now all of the buildings grow at the same time. So that's not nearly as fun as have them randomly up here. So one way to do that is to add a math node with subtract and clamp on, and let's put it in here, and the random value goes to here. And now when we play, the buildings grow randomly. That's nice. Remember these values, like remember to put them like so, float 0 and 2. But what I like to do here, I don't like that there is so many buildings growing in the beginning. I would like it to start from very few buildings, and then at the end there could be like all the rest. So let's put again float curve. Let's put it in here, and this time let's remember that not to the factor but to the value. And let's see my settings. I have put 3. Like click this clipping options and put 3 here. And now let's zoom out and reset the curve, and let's make some sort of exponential growth. Now it's much better. Visually it should be like this, but now it's just the opposite of what we want, or what I want. Now all of the buildings start to grow at the same time, and in here there is only a few in the beginning, and then the rest come along. Okay. So then there is one question: how can we increase the speed of this animation, but not the animation of this node? I mean, like, how can we have the bounce to happen for every building, but to have a faster growth? That happened, if I remember correctly. Well, first of all, you can play with this factor. I don't remember what it does. Actually, that's one way to slow down the animation. It happens really slow now. This might be useful for some projects. Let's see, 0.01. Is this now fast? It's a little bit faster. Okay, maybe that's good enough control. There is a way that you increase. Well, let's try quickly. Let's put 11 here and zoom out and reset the curve. It looks quite the same. Let's put factor to 1 and let's use 3 in here. You can play around with the values and find what suits you best. But these values are nice. I will clean up this scene a little bit. Like so. And let's copy this float, curve float, and let's put it in here and disable the multiply node. Just for now. I will demonstrate how this other method. Now we are using the Vertex Proximity, which happens by having the object info here, and let's get the proximity, the object with only one vertex, and remember to put it to relative so that we can change the position of the vertex or the vertex object. And then I will show you soon. Then let's have the geometry geometry proximity. This goes to here, and the element is point because there is no faces in that object. Then let's use map range. And let's put the distance to value. Let's uncheck the clamp. From minimum is 0. From maximum, let's put 22. To minimum is 1, and to maximum is 0. This is what I found to be quite good. Or also I need to mention this helpful fellow in Twitter who helped me a lot with the nodes. So let's put a float curve once again in here. With factor 0.222, and the result from the map range node goes to the value of the float curve node. And finally we can plug this in to the value of this other curve float curve node. Nothing happens yet because we don't animate, but this is what we want to animate. It looks quite nice actually. So we can make a okay, let's see if I make value, and let's put frame once again here, and let's put this to here. The problem is that the buildings slow down their bounciness. This might be what you want in some cases, but I found, and the fellow who helped me in Twitter found even better solutions. So next to the bounciness float curve, let's add math node, and let's put clamp on, and let's duplicate it and put divide, and let's put the clamp off and connect this to here. And then let's duplicate this and make subtract node and put it here. And one more time, let's duplicate this and make it multiply with a value 4 in the bottom field, and this goes to here. Sorry if this is an absolute mess. And now let's put value node in here with frame, and it goes to the subtract node, and I found a number 166 was good for this. I will label this as offset. Offset growth time. So let's see if we have we are missing one node still, which is, let's duplicate the value and let's put 22 for that. Yes, and that value goes to multiply nodes upper field and also to from maximum. Now we should have everything. Well, we can also duplicate the value and put 1 in here and put it to minimum, because this should by all sense control the growth speed. From my earlier tests, it was the case was this. And now when we play from 0, does something happen? Yeah. As you can see, now the bounds of the buildings is exactly the same from the beginning to the end, which is very nice. I think even though this is quite complicated mess, it's very useful to have it like so. I will most probably make a full image of these nodes for you to see if it makes things easier. So growth speed, we can put 11 here. So now it's very slow, and as we can see, most of the buildings have already grown, so we can use the offset growth time to make it start much later. So now the effect is really slow. This might be also something that you want for your project. That's the point of this tutorial actually. I like to go through these different scenarios, different type of effects that you can achieve with these nodes. So that's the offset and speed. Let's try 0.1 if it starts, or 0.4. Very nice. They could be like grave stones or something. Would be very nice. And you can of course edit this bounciness it can start slow and go all the way to the top and then bounce multiple times before settling down. Let's see how it looks. Very bouncy. Yeah, but let's put 1. This was quite nice. Okay, that's it. And now what we are gonna do, we are gonna combine these and these. So let's remember we made this randomizing effect, which looks like this, and then we have this proximity. Now I can show you actually that we can take the point proximity object and we can move it to wherever we want, and the animation starts from there, which can be handy for your projects. Okay, but now let's combine. So multiply node allows us to do that. So let's unmute the node, and it should be as simple as that. Now there should be, okay, we need to animate the offset a little bit. Or maybe 200. $188. Okay. Now you can see that there is quite a lot of randomization in there, but also it grows from one place. Okay. Damn, this takes forever. The timer is like half an hour or more now. But this effect is finished. So the buildings are now done. Pretty much. They should be. Let's move on to the windows. Let's copy the join geometry node. And let's have the noodle go from the instance on points node to the last join geometry node, and let's put instance on points node also to here, because now we are making the windows. And let's take the input object info. Let's select the window dark, and let's check the as instance original, and let's put it to instance and let's check the pick instance. Now there is a lot of windows for every building, for every direction, so it's getting quite laggy. So for the time being I will use shift right click drag to make a reroute node, or what is this called, I don't know, and control right click drag to cut this line, so that I can demonstrate that when we select these buildings we have a vertex group in the buildings which is yes, it's about the vertices. So these are the places where the windows will be. Here, 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 and not much else. Even the back side and the other side is empty, so that we optimize the scene quite a bit. And here we have this much selected, and in here this much, and all of them use the same name, Vertex Group walls. We can fetch this vertex group soon. Let's go back to the geometry nodes and apparently I used faces mesh to points. And it goes here and faces. Yes. So let's do the selection first. So now all of the faces have one window, even in the roof. So we need to use the vertex group, and that happens by okay, I'm getting a little bit lost here. Let's put it in here. Group input. Input. No, group input. Let's put this here, and we need in the group, in the N panel in the group tab, let's add 2 inputs. the first input is called windows. Is it right? And it's Boolean. So it's either on or off, I think. And I seem to have these checkboxes on. I don't know if they are necessary. And the second input is walls, and that's also a Boolean. Okay. Then we can test it right away. No, we cannot actually. We need to go to the modifier, and here we see the input we just created. Let's click this. What is this? Attribute toggle for both of them, and for the walls we need the building Vertex Group like so. Yeah, I'm just thinking. Yes, because let's select the window dark. This has also a vertex group called Vertex Group window light, and it's only one vertex. It's the middle one. This will be the placement for the lit up window, and the lit up window is just a plain which is a little bit above its origin. So the origin will be on the vertex eventually when we duplicate things with geometry nodes. I hope that is understandable, or that you understand. Let's go to here, and in the modifier let's select the window dark, and let's select the vertex group window light, and put it to the geometry nodes modifiers here like so. Now we can call these vertex groups when they appear in the geometry chain, or so I think. Okay, so we have this group input here. Let's take the walls and put it to selection, and now the scene got a whole lot optimized. As you can see, there is no windows in the backside of the buildings anymore, and there is windows only in the vertex group, as we expect. But the windows point to different directions. Well, no, they point to the same direction at the moment. So how can we fix that? That is also a complicated thing. Well, not that much. That's only three nodes or 4. We need align Euler to vector node. Then we need attribute, capture attribute, and it goes here between the instance on points and of the buildings and mesh to points of the windows. Okay. Capture attribute, and let's put face and vector, and let's call the node called normal, and we want the normal to be in here. Yes. And let's put this to Z. Yes, and the attribute, which is now the normal, somehow goes to here. And now finally this one goes to the rotation of the windows and snap. The windows are there in the correct orientation. Good, but what I like to do is to randomize the amount of windows. So that happens in here, bit near the group input. So let's use random value. Let's put 1.5 in here and float. Then mat node, which is greater than and value is 1, and this goes to the threshold, and then we duplicate this greater than node and put multiply, and the greater than goes to here. Is this even needed? Yes, it is. Here you can adjust the amount of randomized windows. Okay. Let's put it back to 1.5. That's that. Now we have the windows. We are two-thirds of finished here. We have the houses, the buildings, and we have the windows. Now let's have the light up windows. Well, it's not super simple, but let's see. I forgot one node which at the moment is not necessary, but it will become quite necessary. It's the realize instances. And let's put it to here before the capture attribute. Well, it messes up with the windows a little bit. But we can adjust the window scale here. Yes. There is also the problem of the windows staying on the ground, but I would like to demonstrate this later, why this is important. Realize instances. Okay, but let's get to the lit up windows now. So let's take the group output, put it to, let's get some room here, and we can copy quite a lot of nodes here. All of these and instance on points. Yes, and let's duplicate these to here. And we change the window dark to window light. And we don't take this geometry, but the geometry that comes from the windows, and put it here. And we need another join geometry node here, and let's connect this to here. Now there is quite a bit of those lit up windows once again, but only in place of black windows. So now we need copy the group input from here, duplicate, and let's put it to here. And now we need the Windows Vertex Groups, and let's put it to selection. But that's not enough. Aha, of course. This was a good point. We need to put the mesh to points to vertices. Now it's in the middle of the, and only one, and point 7 3. But now there is light for all of the windows. And yeah, that's the end result that we want, but let's animate them to light up. And that happens. Math node, let's add math node and multiply and another multiply with clamp and value 1 goes to here. And yet another multiply without the clamp goes to here. Then let's duplicate this, and this will be greater than. And the value goes to here. Let's put the value to 3 and the threshold we need random value, and the value goes to the threshold. And float, yes. Okay, then let's copy the multiply, and it will become add with clamp. Yes, and we need map range. This is the classic proximity thing once again. Geometry proximity and object info. And let's select the point proximity here as relative so that we can move it. And geometry goes to here. And it's points. We did this already one time, so it should be in near memory. Let's take the clamp off from map range, and let's put 1 to here and 0 to here, and result will go to the add nodes upper field. Now we have something, but it's still not doing anything because we need to animate the. There are 3 fields that need some animation. Let's put so the add node after map range, let's put 0.5, and in the frame 250 let's add keyframe, and somewhere around 500, let's put it 500. Let's add a keyframe of 25. We can change this later, But now, as you can see in the, what is this, the graph editor, there is now the curve of this node there. Something happens, but this is quite stupid that the windows light up so with so clear border. So let's randomize things a little bit on the border. So for the greater than node, let's put 0.1 in 250. And let's insert keyframe with I, and in 450 let's put 4.1 and insert a keyframe. That didn't do much. Well, you can see in the beginning there is some randomization, but in the end there is not. Okay, but we need one more animated value, which is the random value. Let's put 7 point. Let's go to frame 300 and put 7 to the max, and let's insert keyframe, and 450 let's put 1.5 and let's insert a keyframe. Now there is quite a bit of randomization happening. You can play around with the curve values and keyframe positions to find you the best situation for your project. Is that it? Let's make a render and see if everything works correctly. Okay, the render seemed to turn out quite okay. So there is no flickering in the buildings, and everything seems to be good. But there is two more things that you can do, like you can see here. When this blue building rises up, it has those lights on. which is this frame here, and this building here. The lights are on. I tested, it was probably because of this greater than node, which needs to be probably at 0 and keyframe, but I had a reason to put it 0.1. I cannot remember what it was, but now we get rid of that. And another one that you can do, a thing, is to hide these objects on the ground, and I didn't really know how, so I just grabbed the mesh and put it under the grass. Well, that seemed to solve the problem somewhat. Alright, but now it works. Now I'm quite safe to put this to render with all the buildings. You just select this, and it's probably a good idea to disable the geometry nodes from viewport. Go to local view, go to face selection mode and select something like that, and assign them to the vertex group. Now it gets really heavy, but looks nice. Let's see the final render. Alright, that was it. I hope you enjoyed watching. It was a little bit long one, but there was a lot of important information there. So, see you next time in the next video. Bye!